Hello, this is John Burke, CIO and Principal Research Analyst at Nemertes Research. Welcome to the webinar entitled Next Generation Security, Containers, presented by Nemertes CEO and founder, John Attil Johnson. A replay of this webinar will be available in our channel shortly following the session. Today's webinar consists of an interactive presentation and a moderated Q&A period. Feel free to submit any questions you have anywhere along the way using the questions panel in the BrightTALK control panel, and we'll do our best to answer all of them during the Q&A period at the end. And with that, let's go ahead and get started, and I will turn it over now to you, John.
Great, thank you, John, and welcome everyone. As John said, let's go ahead and get started. So what are we getting started on? I'll give you a little bit of background about Nemertes and our ongoing and upcoming research. Then we'll jump right into the whole issue of container security. And in fact, if you don't want to listen to the whole webinar because you're busy, I know it's the holiday season, I'll give you the key takeaway right now. Container security, it's a thing. You have to think about it. Okay, now that you've internalized that, you're welcome to stick around and hear the rest of this. We'll talk about what what containers are, which will give you a pretty clear sense of where their vulnerabilities might be, but just in case, we'll go ahead and enumerate those and then talk about some things you can do as countermeasures. Also talk about how we can assist you in those things and then turn it over to Q&A. Here we go. So a quick bit about Nemertes. We are, as you can see, a global research and strategic consulting firm that analyzes the business value of emerging technologies. That's a lot of words. What it really means is when something new comes along, like containers, we take a close look at what enterprise organizations are doing operationally around it, such as for cybersecurity. Are there new tools required? Are there new organizational structures that need to be in place? Do people need to get trained? What are the processes that need to get changed? So we are kind of the go-to folks to provide guidance and counsel around really the real-world aspects of emerging technology. And just one last thing, we have both lived the life and walked the walk. We don't just talk the talk. John Burke is actually Nemertes CIO and has also been a principal architect in much of his working life. I'm Nemertes CEO, and I've been a chief technology officer for much of my working life. And our other colleagues have similar backgrounds. So that's kind of us. What we do is gather data from leading edge organizations to understand what they're doing that actually works. So when you see any data in this presentation, that's where it comes from. It's primary research from Nemertes. So speaking of primary research, we're working on a couple different things. Right now, John and I are in the midst of our IoT research study. There's still time for you to participate. If you're interested in participating, there's a list of attachments and links that are right here in BrightTALK, and you can click on that and actually go directly to the study and input your thoughts. We are also recruiting for our 2019 Cloud and Security Research Study, so click the Attachments tab to get added to the queue to participate in that research study. And for all of these research studies, we will share the findings with the research participants at the conclusion of the study. With that, let's talk a little bit about containers. And I'm going to lay the groundwork about what containers are and why people use them. And then we'll jump into what the security challenges are. So first of all, containers as a software development construct, container use has more than doubled in the past year. According to our primary research, in fact, John's primary research, we've determined that 21% of the organizations that participated in our research studies were using containers by the end of 2017. That has increased by 114% to 45% by the end of 2018. These figures are ours, but they're very similar to those that you'd get from any other research organization. The bottom line is we are in the steep part of the adoption curve for containers, so now is an excellent time to be thinking about container security. First thing to understand is containers are not VMs. They're similar to VMs, but much lighter weight. What does it mean to be lighter weight? Essentially, the big thing about a container is it's the application plus the associated binaries and libraries, which may be shared across multiple applications if you look at the yellow blob on the right, or it may be dedicated to a specific application. That thing is the container. With a virtual machine, you have the application, the binaries, the libraries, and an entire operating system for this thing to run on, sitting on top of a hypervisor, which may or may not be sitting on top of another OS, depending on how you set it up, which sits on top of a server. In the container world, you have the app, its associated binaries and libraries, the container engine, and then the host operating system and the server. So in other words, there's no separate set of operating systems to lug around. That's really the key difference. We'll also talk about what goes into a container and what the components of a container are, because that becomes important for understanding the vulnerabilities. The next thing to think about when you think about containers is that you're designing an app with its associated binaries and libraries, and this affects the entire software design lifecycle. So not just design, but design, build, test, and deploy. Here's how. When you're building, you have a single consistent environment for application development. So that actually makes it faster and easier to get stuff out if you're using containers. It also means it's faster and easier to locate and fix bugs. And when you go to deploy the containers, you can migrate them across operating environments much more easily. Because essentially everything's self-contained, you don't have to worry about unexpected breakage coming because you're making a call to something that isn't there or isn't where it's expected to be. That means that if you're in the DevOps world, you're also able to upgrade and enhance without breaking components, because you're dealing with each little, I say little, they can be big apps, but little app in its own environment, so you can be absolutely assured that it's got everything it needs, and you can make those upgrades without worrying about whether somebody's made changes to something else somewhere down the line. For these reasons, you get a huge set of benefits from deploying containers, and we'll talk about those benefits shortly. But just to zoom back out a little bit and talk about where the containers fit in the development environment, essentially your DevOps tools are kind of at the top of the stack. So anything you've got that's doing build automation, version control, configuration management, continuous delivery, all that fun stuff sits on top of container orchestration, which then sits on top of all the actual containers, which then sit on top of your infrastructure, which is network, storage, compute, and also increasingly cloud. In general, the typical use case is cloud, whether it's private cloud or public cloud, but increasingly public cloud. However, that's not required. You can actually be doing containers on your own on-prem if that's what you want to do. You also have an image registry, which touches all of these pieces. It's important to understand the relationship of the image to the container. The image is essentially the template, the static template from which containers are built. Images are typically built from layers of images, so it's a layered construct. A good way to think about it is if the container is the cake, the image is the recipe. This is important when you go to think about what some of the security vulnerabilities might be. And then all around this whole environment, you've got monitoring and management. And notice that this is going up and down the stack. So monitoring and management may be happening at the infrastructure level. In fact, for your sake, I really hope it is. But that doesn't necessarily tell you anything about what's going on with the applications and their associated binaries and libraries, or what's going on about the container orchestration. And then DevOps has its own monitoring and management tools, which may not be going down towards that middle. So in a sense, that pale blue pillar on the right is something that you need to really think about when you're thinking about deploying containers, because you probably, if you're like most folks, you probably have a fairly mature infrastructure monitoring and management scenario. You probably have a fairly mature DevOps monitoring and management, but you really want to understand what's going on in the container world. And of course, around all of this, you need to wrap security. And now you can begin to see the complexity of the challenge, because there's an entire ginormous industry that's built around infrastructure security. There's a whole ginormous industry that's built around application development security, DevSecOps. But the gaping hole here, it's not really a gaping hole, but it's something that people tend to overlook, is container and container orchestration security, which is kind of the topic of this presentation. So just to drill down one next step, Kubernetes is one of the most typical orchestration tools. It's something that was developed by Google and released into the wild. You can see all the different components here. I'm not going to walk you through this, but essentially you've got nodes, you've got clusters, you've got your container pods. And the orchestration architecture is really the thing that keeps track of all of these things individually and collectively. And the reason I'm highlighting that is because your orchestration can actually be an area of deep vulnerability from a cybersecurity perspective. Okay, wrapping all this up in our 30-second tutorial on containers is a nice little eye chart, because I figured every presentation needs a wall of text somewhere, right? What are the benefits of containers? Well, the first one, as I mentioned, is you can really streamline application deployment, because you don't have to be doing the rebuilding for different hardware and software. Even with a VM, you've got that, you're lugging around this operating system. The container can run on any system with the container engine installed. So it's basically a universal operating platform. So you don't have to worry about those million and one little details that normally used to have to happen when you were, pushing apps out to different hardware platforms or operating systems. So rolling this stuff out, rolling containers out quickly is very easy. That also becomes a security vulnerability, and we'll talk about why that is shortly. Because as you throw automation into the mix, it's quite straightforward to say, oh, now I can deploy containers very easily with a click of a mouse. Why don't I just set up something so that I deploy things based on resource availability automatically? And that kind of leads to the flock of seagulls problem that I'll talk about in a second. Containers also make it a lot easier to do testing, as I highlighted, because the development and production environments are exactly the same. You don't have to worry about gaps between development and production. Amusingly, John and I were actually troubleshooting something late last night, and the development environment and the test environment the development test environment and the production environment were slightly different. So we had to go to run a test in the development environment, and then in the production environment, which is like, oh God, that's so like 1990s. It really needs to go away. With containers, it does. Obviously, containers align super well with DevOps and Agile methodologies, also with cloud infrastructure. Containers are nicely modular, so you can break down a complex application into little microservices. Each microservice can be an app in a container, and then that means that your tiny little Scrum can be developing your tiny little microservice and your tiny little app and your tiny little container and get stuff done really fast by chipping away at it in a nice modular fashion. And finally, you get the advantage of both streamlined building and shipping, and also improved workload density, because the containers are so super lightweight. The containerized app is easier to build and ship. It doesn't consume a lot of resources, including network and compute resources, and you can get much greater density than you can with VMs on a particular physical server, because you're not replicating operating systems multiple times. So these are all reasons to deploy containers, but if you're looking at things from a cybersecurity stance, you can see why containers can also be dangerous, and we'll talk about that shortly. So what are some of the risks and vulnerabilities to containers? And hold that thought of flock of seagulls in your mind. And by the way, if you're thinking of 80s pop bands, I'm sorry for the earworm, but it is a good image. The first problem is that traditional tools don't make two assumptions that containers break. The first thing that breaks is this notion of application lability. The applications are very labile in a container world, meaning that they change location rapidly and dynamically and appear and disappear at frequencies faster than your legacy tools can support. Meaning that tools have this expectation that an application is going to stay put for a little while because it was such a pain to get it there. Because all that overhead means that you can sort of count on an application continuing to run wherever you put it last. And in a container world, it's almost more like fireflies, or, as I said, flock of seagulls. They pop up here, they pop up there, they disappear from here, they disappear from there. And if your tool is making this assumption that the application is where you last left it, it's going to break. The other problem is because containers are nicely modular and very small, they lend themselves to very granular developments, which means you've got lots more apps than you previously did. Certainly in a monolithic environment, you had one giant hairball of an app. As you moved towards more of a DevOps environment, your apps got smaller and more modular. As you put them into containers, they're smaller and more modular yet, but that means there are more of them. So while each individual app may be small and modular, there's lots more of them. So kind of a nice, handy way to think about all this is, in the legacy application world, every application was a pet. You knew it. You loved it. You tended to its every nuance. You understood its personality. You knew everything about it because there was just one application. As you moved into this virtual machine world, it's more, that move from pets to cattle, where, they're kind of indistinguishable. You are not so emotionally attached to each one because, well, there's always going to be another one. And as you move into the container world, it's that flock of seagulls problem where there's lots of them. They go all over the place. It's very difficult to keep track of them, and you can't make any assumption about where they're going to be. You can put, cattle in a field behind a fence. Good luck fencing seagulls. And that's really kind of the gist of the problem. Now, another good way to imagine this is, in the old universe, you had applications, you put them on servers, and they stayed there. In the new way, you may have a bunch of applications distributed across, various clouds, and they may have moved since the last time you looked at them, and they may have moved again since the last time you looked at them, and they may have moved again and yet again since the last time you looked at them. And so your tools have to be able to handle this high-frequency dynamic lability, really. That's really technically what it is. And that is the fundamental challenge with applications that are developed in a container-based environment. The other challenge is equally fundamental, but sort of more basic, which is, if you go back to that architecture slide that I showed, you've got your DevOps tools and processes, you've got your orchestration, you've got your apps, you've got your binaries and libraries, you've got your image registry, you've got your images. There's more stuff out there, which means more stuff to be secured. And that sounds so simplistic that it's almost something that people overlook, but it actually shouldn't be. Essentially, your attack surface has increased dramatically, and we'll talk about how. There are very specific container risks, and I call these the Big Five. And frankly, a great way to get up to speed on the Big Five is to read the NIST publication. We are in lockstep with NIST. I'm not going to read it to you there, but it's the 800-190 SP. And if you go through it, they go through this in exhaustive detail. You've got image vulnerabilities, you've got registry vulnerabilities, you've got orchestrator vulnerabilities, you've got container vulnerabilities, and of course your host OS vulnerabilities. That's kind of a nice way to cluster things. I'm going to walk through each one of those in some detail, but at the end of the day, one of the things you're going to see that hopefully is going to start leaping out at you as we go through them in this level of detail is that that all of these vulnerabilities have a couple things in common. One is that they're highly configuration dependent. So in other words, if you're configuring things and reconfiguring things rapidly and correctly, you can generally mitigate most of the risks. And the other one is that most of the vulnerabilities exist in the first place because there's a mismatch between the assumption that these things are going to be static, the cows in the field versus the seagulls in the air, versus dynamic. So what that actually says from a cybersecurity perspective is the way to fix everything is through a focus on process and automation. So just keep that in the back of your head as we go through this. So with image vulnerabilities, remember, the definition of the image is essentially the recipe from which the container cake is built. Keep in mind also that they're very complex recipes, so to speak, complex images that are built of layers of other images. And the challenge is they can be outdated. Because they're static files, they can be including things that didn't have security vulnerabilities at the time they first existed, but later got them. And that's a huge problem right there. And again, that's a classic example of static versus dynamic. Next, another vulnerability is image configuration defects, so that as you configure the image, you are actually embedding defects. And that can include embedding malware or embedding clear text messaging, because hackers love to do that. Or you may have untrusted images that actually you can't validate came from someplace that you should trust. And this gets back to the whole universe of developing in the DevSecOps world. You always have to be asking yourself, where did that service or microservice or image or whatever component come from? Who built it and who had access to it? And can I trust it? And if the answer, you should be able to know the answers to all the questions of who built it and who touched it every step of the way, because that's one of the beauties of the DevSecOps universe. But regardless, you shouldn't assume trust, and too often organizations and developers assume trust because that's how they always have done things, and that's where things tend to break. You may also have image registry vulnerabilities. Now, remember, the registry is where you keep track of all the images, so go find this image here. Guess what? You really don't want you don't want to have an insecure connection to your registry, yet a lot of folks don't think about how to secure access to the registry, or I kind of loop, NIST puts it third, but I kind of put it second. Good heavens, what kind of authentication and authorization do you have to make changes to the registry? Is there a hierarchy? Is there a policy in place? Is there a hierarchy in place? So, yet again, it's a case of, well, don't assume that the registry is trusted just because, it's sitting there. It's kind of like the DNS problems in the internet. It's assumed to be trusted, and that's a terrible assumption to make. Finally, you can have stale images in the registry, which is sort of back to the stale image problem, but in this case, the images themselves may be stale. So really what you have to think about is you want an automated process. You want kind of two pieces. One is you want accurate, effective, dynamic authentication and authorization with secure connections to that registry. So you can't get in unless you're authorized to get in, and you're getting in over a secure connection, and you want some kind of mechanism that allows you to prune outdated images from the registry, which means, as you can think about it, you can set a bunch of thresholds and prune the images that trigger those thresholds. And I'm getting ahead of myself into the vulnerability remediation, but there's a common theme here. The solution really is to think in terms of embedding security and also to deploy automation wherever possible. Orchestrator vulnerabilities. Well, you could write a book about this, and I'm sure people have. At the very beginning is unbounded administrative access to the orchestrator. Good heavens, who can control your orchestrator? Because whoever controls the orchestrator has keys to the kingdom. So don't do that. Don't make that mistake. If you have unauthorized general user access to the orchestrator, not administrative access, it still can be bad because I can jump in and, create pods or clusters of bad things as a user. This is a tricky one, this middle one. Poorly separated inter-container traffic is actually kind of interesting because what it means is it's very, very difficult unless you have mentally and organizationally positioned your containers in sort of clusters of consistent priorities and consistent sensitivities. You're going to have a really hard time controlling the traffic that goes between one and the other because you may have some very, highly sensitive traffic traveling on the same path as some totally insensitive traffic. So you really want to think about your architecture as you're putting things together. And same thing with your workloads. And finally, you can have orchestrator node trust issues where the orchestrator just blindly trusts the various nodes. And, once again, you have that problem of having built things with an assumption of trust, and you really need to build things with an assumption of no trust. Oh, by the way, yeah, the containers themselves can have vulnerabilities. They can have runtime software vulnerabilities. They can have unbounded network access, which means if you can successfully create a container, you can now do DDoS pretty much anywhere in the network, which is lots of fun for the folks you're attacking. You can have insecure container runtime configurations. You can have vulnerabilities in the actual apps about which entire college curricula are taught, and you can have rogue containers, which can be either of two kinds: trash containers or direct malware containers. Typically, what happens is as developers are working, they'll just sort of throw some junk out there in the environment, and those are trash containers. As you're building these trash containers, they're not trash when you're building them, but you build them, you use them, you're done. They're still sitting out there. Not only do you not know what they are, but someone can actually penetrate your environment and reconstitute those as, as attacks, and they're points of vulnerability. So as you're looking at this, you're probably thinking, well, duh, if you're cleaning up your environment and getting rid of unused containers, that would probably mitigate at least that bullet item, and in fact, that's exactly the case. So I keep coming back to the notion that if you do two main things, assume every connection is untrusted and think in terms of access and authorization for every component, and embed automation to update things, to delete stale things, and to kill trash to do your trash collection, you're pretty far ahead of the curve. However, both of those actually require a fair amount of automation, and we'll talk about that again in a second. And last but not least, you've got the entire host OS vulnerabilities. Operating system vulnerabilities, again, they taught entire courses on this, probably still do. The difference is because so many containerized apps are sharing an OS, that's an enormous attack surface. If you can compromise the host, you can compromise all the containers that are living on the host, which can be thousands and thousands. You have the shared kernel problem, you have host OS individual component vulnerabilities, and once again, you can screw up user access rights and privileged user access rights, and all the fun things you can do with messing with file systems all apply squared in the host OS. And it's worth noting the payoff is much larger in a containerized environment than in a virtual machine environment, because with the virtual machines, you're lugging around your own OS, so all you can do is blow up that VM, which may be plenty bad enough, but in a containerized environment, you can blow up, the entire ship with, it's kind of like a ferry with all the cars on it. You can blow up all the little cars on it, not just the ship. So host OS vulnerabilities matter a whole lot more in the container world than they used to in the VM world. So what do you do about all this? A detailed description of all of this is beyond the scope of a short 30-minute presentation, but I can point to a couple of key areas that make sense. First, include cybersecurity from the beginning. If you are among the 65 or whatever it is, 65% of organizations who have not yet adopted containers, you're in luck, because you can actually begin to plan your cybersecurity strategy now, grab the security people, force them to sit down and think with you what some of the problems are, and really include cybersecurity at every step along the way. This is one of my favorite quotes from Gene Kim, who I basically think of as the father of DevOps. The days are over when we just reviewed application security and the environment at the end of the project. Now we have to integrate that into daily work. And integrating that into daily work means your developers actually have to think like cybersecurity folks. That's a whole nother area of focus, because most of your developers don't want to be cybersecurity people, or they would have gone into it already. So how do you get that mindset in your developers? Unfortunately, it's not too hard to get the right mindset. Obviously, getting the depth of subject matter expertise is a whole different challenge. But what you can do is encourage your developers to constantly ask questions like, who is going to have access to this? How do I know this is a trusted resource? How do I know this is a trusted resource is a great question to ask every single time you do anything, because that will allow you to uncover vulnerabilities before the bad guys do. And the second great question to ask yourself is, what happens when this is obsolete? Am I leaving a dead container around? Am I leaving a stale image around? What is the definition of staleness for an image? What is the definition of obsolete for a container? The developer probably knows this better than anyone, and if there's a place he or she can be throwing those observations or those parameters so that you can be automating the appropriate treatment, you're way ahead of the curve. So again, include cybersecurity from the very beginning. Additionally, there's some practical steps that you can take. And frankly, I kind of feel like I'm preaching to the choir or kind of repeating the gospel. But any practical steps that you take involve people, process, and technology. And you're kind of going, yeah, right, that's super helpful, thanks. But really, breaking it down that way does help, because what do you do for people? Well, take a look at the NIST framework. They talk a lot about some of the operational models that you have to have in place to implement and instantiate containerized security. Processes, we've talked a little bit about some high-level processes. Again, the NIST framework goes into much greater detail. As for technology, get some. How's that for very basic recommendation? I think if there's one main takeaway here, it's you really need to have a line item in your budget for containerized security. And we can help you with all three. We are, as I mentioned, tightly coupled with the NIST framework, and we help a number of clients do the technology selection part of their cybersecurity initiatives. So we work very, very closely with people, process, and technology based around that whole NIST framework. So obviously, you can contact us, and I'll tell you a little bit more about how we can help in a few slides. Container cybersecurity tools. Here's a short list, not the world's most comprehensive list of tools that you can potentially consider. Which one you choose depends on where else you've got automation built into your environment, what environment you actually are using. I'm assuming you're using Docker and Kubernetes, but you may not be. And also, what it is, where you are in your overall maturity level. So, Tenable, Twistlock. I really do like the Twistlock name. I have to say that it's the best name for container security ever. And if you're wondering why I'm saying that, if you think about it, the concept of a container is essentially built around the notion of a shipping container. And the thing that made shipping containers actually take off was the Twistlock, because you can pile shipping containers on top of each other, turn the twist lock, and essentially guarantee that those shipping containers are not going to fall off of each other and cause a disaster. So the twist lock is key to the security of physical containers, and the company is basically playing off that as part of its name, which I think is cool. There's Aqua, NuVector, Capsulate, Layered Insight, StackRox, Tenable, all of these guys. There's a few more as well. These are kind of the leaders that we've seen. But definitely you should be, if you don't already have a process in place to be selecting among them, you probably should have that. So, what should you be doing next? Your next steps, you should review the NIST spec on container security listed right here. Okay, so go read it. So if there's one thing you do at this point, go read that, because it itemizes a lot of what we've talked about here and explains everything in a greater level of detail. But that's just the first step. Once you've read that and understood what could go wrong, or at least a subset of what could potentially go wrong, you need to take 5 steps back and develop a container security architecture that maps to your container architecture, along with a strategy and roadmap. The difference is the container security architecture tells you essentially what technical components you're going to be putting in place where. The strategy is kind of the high-level principles on which the architecture is built, and the roadmap is the very practical, okay, given that we're going to arrive at this architecture, we're going to instantiate this architecture, what tools do we need to buy when, and how do we need to integrate them in order to get there? Because you can't airlift in the solution. So in light of the above two, then you should, once you've got your architecture strategy and roadmap, once you've read the NIST spec, you should go back and review and revise your processes and organization to make sure that your developers have actually internalized the twin notions of how do I know this component is secure, and how do what does it mean for this thing to be obsolete? And then go out and get the appropriate tools and sort of execute on that roadmap and implement everything that you've got in place. So how can we help with all of this? Well, as with pretty much most everything we do, we provide data-based advice and guidance. So, I mentioned what you want to do and how you want to proceed depends on your maturity level. We actually have a maturity assessment that we can give. We can find out if you're optimally staffed, structured, and funded, and have the right tools in cybersecurity. And that translates to concrete recommendations so that you can move from one level to the next of our 4-tier cybersecurity maturity model. We can work with you to develop metrics, cybersecurity metrics that are relevant to what you're trying to do. As I note here, you can't improve what you aren't measuring, so we work with you to develop the customized metrics based around the NIST framework. And again, I just want to stress that our foundation and foundational rock is what NIST is doing in cybersecurity. We've actually worked with them early on to translate a lot of the cybersecurity framework, the big cybersecurity framework, into a business risk analysis approach. So that's, we've kind of hitched our wagon to NIST. We can help you with that strategy, roadmap, and architecture development. It's incredibly important to have one. It doesn't take too long in most cases, and John can attest to this. In most cases, we really just need to understand what you're trying to accomplish and what your current state is, and building out that architecture strategy and roadmap is relatively quick and incredibly useful. We still use the Nemertes architecture and roadmap that John developed several years ago and tweak it as needed. But once you have it, it's really great to have. And finally, as I mentioned earlier, we can assist with technology and vendor assessment and selection. One of the things we don't do is tell people which vendor is best. And people always ask us, which is the best vendor? And truthfully, the answer is always, it depends. It depends on what you're trying to accomplish. It depends on the environment in which you're dropping the tool. It depends on the integration that you've already got in place or are planning. It depends on the scaling of your organization. Lots of things. What we've developed are some good, quick tools that allow you to plug in what you need to plug in to make these decisions quickly and effectively and customize them to your environment. So that's how we can help. So for more information, if you're a Nemertes client, you can contact client services. If you're not, we'd like you to become one, and it would be great to work with you. And John, I think this is where I start handing over to you to review the attachments, what's in the attachments tab, and tell everyone how to engage with Nemertes in a variety of ways.
It sure is, Jonna. Thanks very much. And before we head into the Q&A period, I do want to draw your attention to a few of the things that we have links for in the Attachments tab in the BrightTALK control panel. Starting with a registration link for our upcoming webinar, episode 1 of our new IoT series, Foundations, Architecture, and Framework, which will be presented on Tuesday, December 18th, by Jonna Till-Johnson. You can register for that webinar simply by clicking on the registration link in the Attachments and Links tab of the control panel. Next, you'll see links to help you join us by participating in our research. We would like to invite you to participate in our upcoming Cloud and Cybersecurity study. If you're interested in participating in that one, source of information on containers, for example, please click on the link, fill out a brief form, and someone from Nemertes will be in touch to get you on the calendar to schedule an interview with either Jonna or myself. By participating in our research, you will receive complimentary access to the results of that research at the end of the study. Similarly, you will see a link to participate in our current IoT study. It's in progress now. We won't be collecting data for much longer, but we are still asking IT professionals who are interested to provide data on their current or planned IoT initiatives. If you're an IT professional and have that information, in exchange for 10 or 15 minutes of your time, we're offering a $20 Amazon gift card to the first 150 webinar participants who provide us with good data from their IoT experiences. All of the information and data provided are kept confidential, of course. And again, by participating in our research, you'll get complimentary access to the research study results at the end of the process. We would greatly appreciate your time and your insight. And in that same spirit, just for attending this webinar, we will send you our container security report when it becomes available. Lastly, let me draw your attention to a link for more information about our own Navigator 360 conference. This year's theme is Digital Transformation 2020 to 2025, Emerging Technologies that will drive business value. The conference is being held May 20th through 22nd in 2019, and we will be highlighting the top technologies you need to consider for your organization over the next 5 years, setting yourself up for what comes after that. And we'd love for you to join us, so you can click on the link to get more information about that. Now I will leave this information up on the screen while we dive into the Q&A. And if you haven't already submitted questions in the questions panel, now is a good time to get it in there before we run out of time. I'll get started with what we have. And question 1 is, Jonna, what is the single most important thing to take away from this whole discussion?
Oh boy, you asked a tough one. I don't know where that came from, but whoever it is, thank you. Because if I had to boil it up into one takeaway, I would say make sure there's a line item in your budget, or preferentially in the InfoSec budget, for a container security tool. As I mentioned up front, you know, there's been plenty of time to think about securing the infrastructure and securing the DevOps world, but containers are sufficiently new that most folks have not thought through the fact that they really need to have a line item in there saying, what are we going to spend on a container security tool? So I'd say put a line item in there and then figure out what tool you're going to buy later. That would be the single biggest thing.
And it looks like the message is getting through, because the very next question is, okay, we'll budget for container security. How should we decide how much to spend doing that?
I'm going to punt on that one, to be honest, because the vendors are extremely, as always, they're extremely variable in how they do their pricing. So unfortunately, I know you'd love to have a nice normalized rule of thumb cost for this. I don't have one as a rule of thumb. Certainly something I can get back to you on if it's of interest.
I will throw in at this point that our general yardstick for budgeting in security is to assess the risk that a particular piece of the security puzzle is fixing for you or mitigating for you. Risk-based budgeting is our general guideline. So if you're going big into containers, you should be thinking about how much risk that is going to be exposing your organization to and budgeting accordingly to secure it.
You know, John, that's an excellent point, and I'm glad you highlighted that, because what I would not want to do is think in terms of a percentage of what you're spending on containers, because essentially if you're putting the crown jewels into containerized apps, and even if you've managed to do a really good job using a lot of open source technology, you still want to spend a lot of money to protect your crown jewels. So good point. Tie it to the importance of what you're rolling out.
Okay, next question. Everyone around here is talking zero trust. How does container security fit into zero trust thinking?
That is a great question, and I'm delighted to hear whoever said everyone around here is thinking about zero trust, because that's a good thing. Kudos. Basically, one of the there are two key components of zero trust that apply extremely strongly to containers. The first one is increased granularity. You know, I keep talking about going from the dog to the cattle to the flock of seagulls, and as the entity that you're dealing with is increasingly granular, that's actually a facet of zero trust security as well, where you actually push your, I think about zero trust as really being distributed trust, and you distribute it at a highly granular level. So just because you trust one application and its associated, binaries and libraries doesn't mean you trust another one that happens to be operating, executing on the same exact OS. So it ties in perfectly with this notion of increased granularity. And the other piece is what I kept highlighting early on, trust no one. So developers should always be thinking in terms of, if I make this call, if I deploy this container, how do I trust that the components are what they say they are, haven't been compromised? So again, it dovetails very nicely with the fundamental principles of zero trust, which is really highly granular, highly distributed levels of trust, something we sometimes talk about as being deep segmentation, and a requirement to validate that trust at every level.
Thanks. And that is actually the last question that we have at the moment, and a good place to draw a line under it all then and say thank you. Thank you, Jonna, for all of your insights, and many thanks to all of you who have joined us for this session, for your time and attention, and for the great questions. Again, the replay of this webinar should be up in our channel on BrightTALK shortly. If you have found this valuable, please share a link to that replay with your colleagues, and please take a moment to rate the session and send us feedback. It's much appreciated, and it helps us decide what to do next in our upcoming sessions. If you haven't already, check out the links in the Links and Attachments tab, and do check back often in our channel. We post new content pretty regularly. With that, I'll say thank you very much for joining us today, and this concludes the webinar.